Yeah, all right, we're going to go ahead and get started. Welcome to our Friday seminar, and welcome to all those who are listening in via webinar. Today, I would like to welcome John Gann. He began his career in the marine industry in 1985 with the USGS Marine Facility in Redwood City, California. And in 1991, he founded Chesapeake Technology, and it initially provided software consulting services, and then it moved into product development. And he has delivered software development, consulting, and training to navies, law enforcement, agencies, sonar users all over the world. And he's going to tell us a little bit about that today. So, turn it over to you.
Thanks, Nikki. Firstly, I'd like to thank Monica, Nikki, and Will for this pretty magical seeing all this stuff set up here and with the webinar stuff into it. So that's pretty cool. Thank you very much. So my challenge today is to kind of convey to you guys in about 50 minutes what we normally take about 3 days to do. So it's going to be kind of very wide and not very deep. But if I invite you guys to ask me questions, I'm going to hang around a little bit afterwards. And so if you have some questions, feel free to attack. My title is the VP of Engineering, but I'm really the guy to blame. That's what it says in the dictionary. Chesapeake is a small company. There's just 5 of us. My wife, Eileen, is the president, and she is a mathematician by training, and she has an MBA. And so she kind of runs the business side of the business. Ashley is a relatively new person. She's been here a couple of years now. And she does the marketing and admin. And then we've got a full-time tech support guy who's an old friend also. Been around the tech industry, but it's kind of new to Sonar. So he's kind of coming up on a learning curve. So if you talk to Steve, be patient. He's a pretty bright guy. And then Mark, I don't know if anybody's met Mark Rational, but we've worked together for about 25 years. So we both have some history working for Trimble, and Mark went from LSU. And yeah, so we've been around quite a long time. The company's been around about 15 years, and we've stayed the same size. So that's kind of by design, I guess. Other than the core 5 people, we use our kids who worked on the company throughout the years and contractors as well. And we have kind of an alliance with small companies, so we use actually one of Larry's grad students, Mike Brissett, has a company called Mosaic Hydro. And Mike normally does most of our training. He's a professional training guy, and I'm just an engineer that's...
You know what that means? It means if you graduate, you can then start a company.
Yeah.
You got to graduate.
I've been here a couple of years ago.
Yeah, that's right.
It was really good.
We are based in Mountain View, California, despite our name, and we're just like 2 blocks off the train station and just down the street from the brew pub, which is also our conference room. So if you're in town and you want to come and see us, we'd love to have a visit. Okay, so I'm going to get right into a couple of more slides, and then we're just going to get right to the software. But I wanted to introduce it by just basically telling you what you can do with SonarWiz. So it's divided into kind of 2 parts. You can collect your data with it, or you can process the data with it. So that's the big division, and the 2 ways we both sell it and support it. So on the data collection side, you've got these little blocks in the middle there represent all the sort of functional things that you can do with it. So there's a whole navigation section that allows you to do survey planning. Just actually last week at NAVO, we released our autopilot control, so now you can set up your survey in SonarWiz and output the autopilot messages and actually drive the survey lines. And custom outputs, so if you want to send data to another application like HiPAC or Sonar Pro or something, you can do that with our custom outputs. And then we have an older helmsman's display, which is kind of an old version of SonarWiz that is just like SonarWiz, except it doesn't display sonar data. And you can have those sprinkled around your lab or your boat. They don't require a license or anything. They'll just run off the UDP messaging. We've got interfaces for most of the commercial side scans. So clients, EdgeTech, Imagenics. We have real-time interfaces for most of those guys. Sonic, and then same for the sub-bottom profiler. So the EdgeTech, whatever they call it now, 3100 or Klein 3000 with the sub-bottom attachment, the older analog geopulse systems, any analog system in fact will work. Magnetometers, the C-SPI and Geometrics. Let's single beam up there. We really don't do single beam very well. We collect the data, but we don't have a whole lot of processing for it. We don't have any kind of tide correction, but it's something that we're probably going to develop more. And then finally, motion sensors. We added some support for bringing in the octans and TSS, primarily for correcting the sub-bottom. We use that real-time heat compensation to do the the sub-bottom direction. So that's just a kind of a block diagram of the data acquisition. And then on the processing side, this is kind of the same thing. So on the front here, in these blue boxes, we can read in almost any kind of Sidescan data that's stored in a public format. So XTF, the EdgeTech JSF, Klein's SDF, Geoacoustics RDF, and so we can pull the backscatter out of all those sorts of data types, and then we can process that through. Same with the sub-bottom. SegY is kind of the common denominator for sub-bottom data, and the EdgeTech JSF, Newton KDB, a few other spattering formats. I think we do the SideQuest OEC formats. Magnetometer, that comes in kind of in ASCII files, and we can process that through. And the green blocks over here are what you get out of SonarWiz. So primarily, people that are processing Sidescan data want to get a geo-referenced image. So SonarWiz outputs geo-images, and not just geo-images, not geo-TIFFs, but like geo-PDF, geo-ping, geo-JPEG, and so on. So there's several different formats for that. Websites, your whole project can come out as a website, so you get the little mosaic in your browser, and it's all cursor tracks, so you can get the geodetic cursor position and XY cursor position in your browser. Waterfall views, targets, etc., all on a web browser. Google Earth, everybody's got that now. You can take that geo image and plop it onto Google Earth. Contact reports, I'll show you that in a bit. That's really nice in the new version of the software. That lets you capture your sonar contacts, and it's all put in an SQL database. So when you get 500 or 2,000 contacts, you can start to run queries and filters to find out, show me the contacts that are more than 5 meters off the bottom and that were classified as obstructions or something. So that SQL function is really, really nice. And we generate reports in HTML, PDF, Word, and OpenOffice now with the software. Vectors, so things like points, lines, and polygons that you digitize, they can be exported as shapefiles and DXF files and KMLs. Coverage reports, how much area did I cover in my survey? How much area did I map? How much did this particular line contribute to the total coverage? So we've got these little coverage reports that come out as Excel spreadsheets. Mag anomaly reports is pretty obvious. So if you go and digitize your mag anomalies or you auto detect them, you might want to get those out and generate those reports. Gridding and contouring, and then 3D views. So we have exports to the IVS product, so we can generate SD files most of the time. We're still working with that. Mark Patton's been helping me get the code to generate SD files directly from SonarWiz now, so we can go right into FreedomMouse with that. Yeah, so that's again a quick block diagram of what you're going to be seeing, and that's the last slide that I'll make you look through. So without any further delay, let me just ask one other question. How many people in the audience, a show of hands, are familiar with Sidescan Sonar? Great, so almost everyone. And how about sub-bottom profilers? Okay, and anybody interested in magnetometer here? Okay, good. Good, that's what I would have expected, but I just want to be sure. So here's SonarWiz. And when you open SonarWiz, it opens the last project that you use by default. So this is the last project that I was playing around with. This is some Klein 3000 data that actually Gary Kozak, I think, collected. We use this in our training class in December, and I'd like to show you work with this data set today. But before we get started, I'd just like to go around the display and kind of show you the anatomy of the window and what the different tools are, and give you a little bit of kind of background on the layout. So we've gone with the Microsoft Ribbon kind of layout there, and what we've done is we've tried to group functions into these different categories. So on the data acquisition part, you'll find that there are buttons here for setting up your vessel, setting up your sonar, your navigation sensors. So these things just lead to dialogues that help you set up the thing that they're configuring, right? So there's one for each of the sensor type: galvanometers, magnetometer, heat compensator. You've got a cable payout meter, and then this is the output devices. So I think that's pretty straightforward. And then other things that you would do in real time. There's the add survey line. So if I want to add a survey line in here, I can just come and drag a survey line. I can generate a grid. Once I've got one survey line, I can generate parallel lines and orthogonal lines. That's all pretty simple. A line manager to do all that kind of stuff, to export them, to clone them, and so on. And then these are the recording buttons. So if I want to record the data, we give you a choice. If you've got multiple sensors connected, you can say, I want to start my sonar here and record that in this file, or I want to record my fathometer in that file, or magnetometer, and so on. These are grayed out because we don't have any sensors connected right now. Or we've got the quick record button that just does a quick click, a single click, and it starts recording in the default file name that you previously set up in your preferences. Okay, real-time mosaic. Sometimes users, they're out there for surveying for a month at a time, and they're collecting hundreds and hundreds of sonar files. You might want to see all that stuff at one time, but typically you're only going to want to keep the last maybe 5-10 lines on the screen. So this little button here is handy. It lets you say, how do you want to do the real-time mosaicing? You can turn it off. I don't want to see any of it. Or just show me the last 5 lines. Don't draw the stuff that's 20 miles away. I don't care about it. Or show me everything. Okay. So these are all the real-time tools. Anybody use thermal plotters here anymore? I think maybe some of the old survey companies still do this, but there's an interface for driving that. I won't go spend any time on that. These are gain settings for when you're in real time. So there's a gain control for Sidescan and sub-bottom, real-time bottom tracker, and eventing. So I don't even know if anybody's doing eventing yet.
Do those gain settings change the raw data or just what's displayed?
Just what's displayed. They do not affect the raw data that's recorded. Okay, so that's the data acquisition panel. And if you just buy the software for post-processing, you'll never see that panel because it's not enabled when you get a post-processing license, which I think is what the UNH license is set up as. So, so you guys would start with this tab, which is post-processing. And this has got the tools that are likely things that you want to do in post-processing. So I've created a project. What I want to do, I want to import some data. So here's where you import your Sidescan files, sub-bottom and magnetometer. Playback, this is something I'd love to take out of here. This allows you to play back an XDF file or a SegWi file in a scrolling window. I don't know that many people use it anymore, but it's useful at trade shows. Kind of have something moving on the screen, catch somebody going by. But anyway, that's what that's about. The file manager is a big old beast. It's kind of the heart of the program at one time, and we're trying to kind of make it a little bit smaller now. But this is where you go to kind of see all the files that are in your project, what extents, what are the graphical extents of those files, and then you can do lots of different options. You see there's a zillion buttons on here for doing things in a kind of a batch way. Then once you've got a Sonar file selected, so we'll go through some of these functions here. These are Sonar file processing buttons here. So with a single click, I can turn on auto gain or beam angle correction, user gain. I can open the bottom tracker, for example, on a given file. So when you highlight a file in the map by clicking on it, this blue perimeter indicates that that's the file that's selected. You can click on one of these buttons at the top and get to that particular feature. Okay. You can also do all this stuff through the right-click menu. So if I click on a survey line, I get this context menu of stuff that I can do with that line. So right-click is used a lot inside SonarWiz. So the digitizing view and the bottom tracking view are 2 waterfall views. The only really difference between the two is the digitizer allows you to kind of digitize stuff other than the bottom. So I can generate circles and polygons and lines and points. And the waterfall view is strictly for detecting the seafloor. Nadir transparency, the Canadian Navy likes this. If you want to make a certain part of the nadir region transparent, so maybe you've got 200% coverage of your sonar data. For example, let's just consider this mosaic here. You can see the nadir area in any sonar. It doesn't image well because of the geometry, right? So if you want to get rid of that, if you've got data underneath of that, the nadir transparency lets you take that section and some distance about the nadir and make that transparent so you can see through to the sweet spot of a file that's lying underneath of it. The order of the mosaic, right now it looks like we might be in shine through mode, but you can change the ordering of sonar files just by clicking on them and using the order to bring to front or send to back. I'll talk about that when we go to the view panel a bit more. Navigation, we have a navigation editor, a very simple little navigation editor that lets you displays the navigation track for that entire file. You can do some smoothing on it. You can pull out points, flyers, and stuff like that. And it's got this little graph at the bottom too where you can look at different parameters in the data. Right now, this is graphing altitude, but you can choose graph data and look at any of the parameters that are pulled out from the file, so cable out and stuff like that. And you can apply some smoothing in here as well. So this little program is also known as Z-Edit. If you click on a file and choose navigation, that's what's gonna pop up. Again, Kind of moving on, we haven't captured any contacts yet, but this section here is all about contacts. By that I mean sonar contacts. Places of interest in the sonar imagery that I wanted to call out and save as something special. Feature Manager, this is the points, lines, and polygons things I talked about. You can click on the mosaic or on a waterfall view and maybe outline the boundary of a sand pocket or something that's too big to be a point contact feature, maybe a bigger area.
What is the waterfall view?
The waterfall view, just to give you a demo of the waterfall view, I can right-click on this and say, digitize new features, and it opens up a waterfall. We call this the waterfall view, and it's basically just a time series of every ping in the file. So you've got the entire sonar file showed ping after ping after ping, just stacked on top of each other. Kind of like what you would see in real time as each ping comes off the sonar. Since we have this window up, it's nice. SonarWiz really benefits from having dual monitors. But one thing that you can kind of see is maybe as I move the cursor around in this waterfall view here, it shows the cursor location in the map. And that's kind of handy when you can always see things better in the waterfall view than you can in the mosaic because it hasn't been really distorted by the geographic projection. It's kind of a handy thing. And this is what I would do. This is the window I would go to when it comes time to capture my contacts. That's the window we're going to come back to.
Does that work the other way around?
It does. It doesn't work as well. Let's see if I can show you. Bring that back up again. Let's see. So if I move the cursor over here, see that white line there? I have to be, it's kind of hard to show on one monitor, especially my laptop doesn't have a whole lot of screen space here. Let's get that spot right in view there. There it is. Yeah. So that's the cursor position that we're looking at. Features up. So then again on the post-processing, we've got a little section here for sub-bottom. When we get to the sub-bottom project, I'll show this. This is intersections is a function that allows you to compute all the intersection points between your sub-bottom lines. So wherever your sub-bottom lines cross, it'll pull out those intersection points, and you can do some things like look at those intersections in 3D using the IBS viewer, or you can list them and report on them and stuff. Cores, if you go out and you do a sub-bottom survey and then go back and do some ground truthing with a gravity core or a piston core, you can take your geotechnical interpretation and put that right on the sub-bottom profile. So you can say I've got a couple of meters of sand under a shell and blah, blah, blah. You can put those cores on the image as well. Magnetometer, that's pretty obvious. So we've got a nice little post-processing section for magnetometer. And then this is our newest function, classification. This is not officially released. You can use it. It's got a big warning that you shouldn't use it yet, but I'll show you what we've done with it so far. We're hoping to kind of finalize it by the end of the first quarter. I mean, it works for Google, right? They put all kinds of stuff out there that doesn't work. So. Okay, we're almost done here with the kind of the anatomy. Again, this is the main map window here. This system information panel. This is mainly useful for real time. The stuff at the top is not useful at all, so I usually use this little control to turn that off. But this system information panel in real time, you can configure all the things that you want to watch. So you click on the gear, and you choose the variables that you care about monitoring. So all the stuff, Sidescan, sub-bottom position, altitude, event number, GPS quality, yada, yada, yada. So you can kind of configure this thing and save that setup and reuse it again later. Most of these windows are dockable, and you can just kind of move them around and dock them to get the screen set up the way you like it. So when you've gone through and configured the screen the way you like it, you can then save that as a layout. So I think that's mentioned in the little blurb on this thing. We can save the layout of your screen. You can save it as Jim, and then if Nikki comes on after you and sets it up her way, she can choose Nikki's layout, and you can go back and forth. So if you're on a boat and you like to configure a thing a certain way, and then the next watchstander wants to send it some other way, you can have your preferences. Okay, so that's sort of the layout. Again, it's real configurable, and you can make it the way you want it. These buttons, these are pretty obvious, I think. This is sort of the universal symbol for panning. You just click the hand and drag the map. This is the rectangle zoom. We use that already, so if you want to zoom in on a certain part of the mosaic, zoom in by 10% is this guy, and out by 10% is that guy. This one's good. This is the little circle here with the sonar in it, this is zoom to sonar extents. So if you get lost, you forget where your data is, it's a good one to bring you back, kind of center you up on the sonar data. And then the one right next to it is zoom to everything in your project. So here we've got this big nautical chart on our project. Kind of shows you a little bit of context. This button here is new. We call it the swipe button, and we swiped it from ArcGIS. I don't know if you guys have seen this tool in ArcGIS, but it's useful for if you've got, we use this for change detection. So say you went out and made a mosaic last year in a harbor, and you got everything mapped out, and you saved that and archived it. And now you got to go back out and do that again because you got to do it again. And so you bring that in, that old mosaic in as a base map, just like I've got the nautical chart here. And if you want to see if there's something new this year that wasn't in there last year, this swipe tool is very handy for that, because you can kind of peel back last year's data and see, or peel back this year's data and see last year's data underneath it. So it's a kind of a handy little tool. The measure is obvious. You can measure range and bearing anything on the map. It's pretty handy. This one is really for real-time applications. It keeps the ship in the view. Sometimes that's the default operation. It always keeps the ship in the main view when you're collecting data. But sometimes you want to turn that off. You want to go plan tomorrow's survey while you're collecting data today. So that's what that button's for, as you go look someplace else. The info button, this is kind of a neat one. If you just let the mouse hover over anything on the screen, it gives you a little pop-up of what's underneath of it. So I put it over a sonar line, and it gives me the file name, ping number, heading, speed, course, etc. If I put it over a survey line, it gives me, I can get it right over a survey line, I guess. The bottom line is whatever you put it over, it gives you information about that object. So you put it over a contact, you put it over a shapefile, and you get kind of complete information about it. This is redraw, stop redraw, capture a contact, and add a survey line, add a feature. Okay, so that's sort of the real quick overview, the anatomy of SonarWiz and some of the functions that are available. Let's just jump to a project. So this is a project that I kind of was messing around with on the plane yesterday. I've got one this is basically the same data that I've already processed out. I've done a little bit more to it. So this is we're going to look at the same data set that's had some gain applied to it. Okay, so this data set here is exactly the same, Klein 3000. We're looking at the high frequency channels. I think the only thing different that I've done here is I've captured some contacts, and I also applied some gain to these sonar files. So to look at how the gain's applied, let's just right click on one of the lines and look at what I've done. Under the gain settings, there's about 5 different options for applying gain. We've got something called beam angle correction, which is Bill Danforth's algorithm. He's the USGS guy. For correcting the sonar just based on its geometry, assuming a flat seafloor, and you're basically correcting for the angle of the sonar beam as it progresses out to the side. It works pretty well. I used to like it a lot, but now I think we've got stuff that works better. Automatic gain control, that's just a kind of an adaptive automatic gain that looks at the kind of the data as it's running and tries to figure out what the best gain is to correct the data and normalize it. Auto TVG is very similar. It's actually a former Klein employee wrote that for us. It's what's used in Sonar Pro, but very similar, I guess. This is the one I want to talk about a little bit. Is you call it EGN. It's for empirical gain normalization. And I didn't write this stuff. I don't have the brain cells to do it. But the guy that wrote this is a guy named David Finlayson at USGS. And it's kind of like our version of geocoder. I know geocoder is kind of I guess a horrible word here. But geocoder models all the angular dependencies of the sonar and the seafloor and so on. And it's very good and very impressive. What David did, he took a kind of a different approach. Instead of trying to model all that stuff up front, he's tried to do it empirically and not really care about what the angular dependencies were, and not really trying to get true backscatter, but to try to get a nice looking mosaic. So what we do is we take what he does is he takes for each transducer and he builds a big grid where the y-axis of the grid represents altitude of the sonar and the x-axis of the grid represents the range. So every time he encounters a sample, and you can imagine there's millions of samples in this mosaic, a small mosaic like that, every time he encounters a sample at some range and some altitude, he puts that amplitude value in the grid. And so he builds these grids up for each transducer, and then he uses that to correct the data, and that's what we've done here. So the EGN is kind of my favorite gain of the month here, I guess, right now, and I use it on most of my projects. So you have to do your bottom tracking first, because you got to know what the altitude is. Everybody know what I mean by bottom tracking. You got to figure out how high off the seafloor the sonar is. But anyway, that's the gain processing that we do. And if I just turn it off on this one line here just for a second to show you what it looked like without it, just to remind you, zoom in here. So without any sort of normalization to correct for the geometry of the sonar, you get this bright spot in the nadir, right? You get this kind of bright spot, and then the trailing kind of sonar signal falls off to the outside there. So what the EGN has done, and lots of functions will do this, right? TVG, some people use TVG for this. There are lots of ways to do it, but I find this one to be consistently pretty good, and it kind of requires the least amount of work to get there. So again, to put it back on, you right-click on a file and say Settings and apply Enable EGN. So with SonarWiz, we try to make things so that they're kind of easy to do. And so if you have a lot of lines in your project, you're not going to want to be doing all this clicking and turning things on and off, right? So say, for example, I want to make, let's make this nadir transparent. Let's use that nadir transparency thing I talked about when we first started. So we're going to set the transparency about the nadir to, let's say, 5 meters on this file. So if that's the setting that I want on this file, you can see we've got a big hole here in the right in here where you can see through the file, and I'm seeing the underlying data in here. If this is a function that I was interested in, and I had 50 lines in my project, I'm not going to want to go right-clicking on all the files to extrapolate that one function. So instead, what you can do is you can use the Sonar File Manager, and inside there's a button called Make Like Selected. And the idea is that you take the settings in the top that you want to take from your reference line, and you can apply that to all your other reference lines. So I want to take my EGN settings or my TVG settings from that one reference line. I've made that look the way I want all of them to look. I can check the box. So in this case, I'd say transparency, and I want to apply it to all the other lines in the project. So when I press OK here, hopefully it'll go off in the background. It'll start to process each line in turn and put a 5-meter transparency in each of the files. So I can see it's working here at the bottom, and as it finishes each line, it should be read. So now you can see I've got a big 5-meter transparency in each file. So the idea of this is that this is how you extrapolate things on one line to things on other lines. And then to put that back the way I want it, I can just turn it off, which I can do it right here from the right-click menu. I can clear the transparency on one line or clear it on all my lines. So that'll put the data back in there. So if you come up with something where you spent a bit of time maybe messing with the gain curve or something that took a bit of manual effort, look to that Make Like Selected button to extrapolate your work a bit farther. Okay, so let's get to contact capturing. These little blue symbols on the screen here, these represent points of interest that I've captured contact already. If I use the little map info button again and I put the cursor over a contact, you can see I get a little pop-up window that shows me what that contact looks like. You can also just move the cursor over it and right-click and say Edit That Contact. So these are things that I've captured already. This is what I did in preparation for coming out here. You can see this is a tire. You can zoom in on that tire. I think that's a tire. And you can measure it. And do this is kind of the obvious stuff that you think that you probably want to do. There is some basic image processing that you can do. There's a gamma correction function, so you can grab each of the color channels and edit that as well. But the idea here is that you capture points of interest in your sonar data, and then you save it and you report on it. So if I wanted to classify this thing, I can click on this button next to classification and say this is a tire, and I'll press OK or go to the next button, and so on. I go through my list of contacts that I've captured. Now, how did I start this whole process? Well, if I wanted to capture a contact, the way you start is you pick up this capture contact tool, and you can just look at something on the mosaic. So here's something of interest right here. Here's a little blob. Let's go see what that is. So when I click on the mosaic, SonarWiz opens up the corrected record to that location where I clicked, right? So it's scrolled down partway into the view here, and it's like a little fish blob or something. And if I move the cursor over this blob, it's around there where I clicked, I think. Maybe I clicked on this one over here. It's kind of hard to do this with this monitor. But anyway, let's just scroll through here. Let's find a point of interest, something that looks interesting that we might want to digitize. Some sand waves. And I'm just using my wheel mouse here to scroll through the file. Okay, here's a bunch of debris, but I've already got a contact there. Here's an outlier of something that should have been over here, maybe. So as I capture the contact, this is contact 20, it puts it on the map as well. So each time you click on the waterfall, you get a symbol on the map. You can use different symbols and colors and stuff like that. Okay, so I've captured my contacts. What can I do with them? So this is the contact manager. Here we're back in the post-processing tab under contacts. This lists all of the contacts in your project. So you can see I've already been playing around here a lot. I've got a bunch of them. And if you double click on one of the rows, it brings up the contact editor. And again, you can zoom, measure, do some image processing as well. But what I want to show you now is the report generator. This is one of the kind of the strong points of SonarWiz, I think. It allows you to generate reports in several different formats. This is called all targets. And I'm going to make an HTML report, but I could just as easily make a PDF file or an OpenOffice or Microsoft Word. So what this does is it goes off in the background, and it has a little utility that builds basically a web page with those contact images in it. And when it's done, it'll open up your web browser, whatever it is, and show you the summary of what we've captured. So here are all the contacts that we captured. It's a little thumbnail image here. Here's the rec. And if I click on it, it opens up the full resolution image that we saw in the report. So a little bit chopped off over here in my web browser. But this last column contains things that I measured. So, I measured the length on some, the shadow on others, and all that information shows up over here. So it shows me the contact width, length, shadow, etc. Again, this is something that you can just give to a customer, and they can look at that in their web browser. Okay, so that's the contact report. Let's just go back into Contact Manager. You can also generate S57s. So if you want to update your ENCs, we generate obstruction files with our contacts. So it's a free tool for making S57s. Geotips will take that contact image, which is a kind of a time series, and rotate it into whatever map projection that you're using. So you can put those into your GIS on the map. You can also import contacts from other SonarWiz projects. The thing I want to show you about, I mentioned in the introduction, is the database that's behind this. If I've got 10,000 contacts in my project, and I just want to report on the mine-like objects, or just want to report on, in this case, tires, I can use this filter tool, which is just basically writing a query. So what I want to do is I want to make a report that just has my tires in it. So I'm going to say, show me everything where user classification is equal to tires, and write that. And you can make these things as complex as you want, right? They can be compound. I could say where the classification is equal to tires and the length was greater than 2 meters. Maybe I want truck tires or something. So you can kind of let your imagination go with this. But if I apply this query to the contacts and press OK, everything I see on my map now is a tire. Okay? And everything in the contact manager is a tire. So if I go back to the contact manager again and I build another report, let's build a PDF file this time. Call it tires. Everything that pops up now in Adobe will just be the tires that we captured. So zoom out here a little bit. So here's Adobe PDF with the contact image. Again, that same information that was in the web report, just in a little table below it. So again, it's kind of the power of the database here, and you can kind of let your imagination go with what you can do with that, especially in a large project. Okay, I got we're going to stop at 10 of, and I'm going to take questions at that point, so I'm going to try to keep moving faster. The feature digitizing, this is kind of neat. If you want to outline a specific area, maybe you've got some some sand and gravel, this little pocket here. I can digitize a polygon or a square or a circle using the feature tools. It's pretty straightforward. That's going to be exported to DXFs and shapefiles and so on. You can also do this in the Waterfall View. I'm going to just briefly introduce the classification product here. Again, you get this warning when you click on the classification button because it's definitely not done yet. But the idea is what we're doing is we're using something called a grade level co-occurrence matrix, which I guess is used to look at pictures of your liver. But it lets you set up the number of classes that you want to try to find in the Sonar mosaic, and a bunch of settings for which attributes are you going to try to classify on. So the two, I think, the default ones are standard deviation of the amplitude and entropy. They seem to work pretty well. This takes a while to run. I ran it in the hotel room this morning, and it took about 10 minutes on this particular data set. So I'm not going to run it, but I'm going to show you the results of what I got this morning. So the classification tool generates two different outputs. It generates a map, a georeference map of the classification, and it generates AutoCAD or shapefile drawing of the outline of all those polygons. So I'm going to load up, using the map manager, I'm going to load up, actually I've already got it in here, the TIFF that was built by the classification object. So let's use the swipe tool here. Hopefully it's not under the map. I've got to turn the map off. Sorry. Let's turn this chart off. Okay, so now you can kind of see what we've got. Let's look at this area right here. We've obviously got some sort of different texture on the seafloor. So if we peel the sonar data back, you can see we've got a classification region that's different for these different types of textures on the seafloor. We've definitely got some kind of a long track function, features that are not part of the seafloor that we've got to work on yet. But this is kind of where we are with it right now. And it's looking pretty good for some of the data sets we process it on. We've done quite a few data sets from the GeoSwath, and it works pretty well with looking at the backscatter from the GeoSwath. So that's our classification product. I guess that's, I need to talk about the outputs of the outputs. So you've made this nice mosaic, and you want to do something with it, right? You want to give it to a customer, you want to publish it, or do something interesting. So SonarWiz has a function that lets you make geo-images. I've been talking about this. And this is it here. You export a geo-image, and you can choose between GeoTIFF, JPEGs, and so on. I'll just do the GeoTIFF one here, and I'll put this mosaic at, say, 50 centimeters per pixel. And you can do stuff like, let's launch our viewer. You can smooth the image if you like. Let's start with that. This will take a few seconds. So what it's doing is basically just tiling up that image and sewing it all up into one big TIFF image. And it should open up our system viewer for TIFF when it's finished.
And it's going to show you what you had in view?
Yeah, there's a couple of choices for that. You can either tell it to show what's in the view. That's what it does by default. Or you can also clip it to a vector feature. So if you draw a rectangle in the map, for example, you can say clip my or circle. You can have it clip to that particular vector shape. So it's actually that's kind of handy to do. Like if you want like a reconnaissance level view of the whole area that you map, you can do that at maybe 1 meter per pixel, and then highlight a certain area that's really interesting. You draw a circle around that, and I put that out at 5 centimeters. So, okay, so I think it's done, and it's just opening whatever the viewer is for GeoTIFFs, which is kind of messy here. I'm not sure what I did there. Let's try clipping it to a circle or something just to show you what that looks like. So to get the circle on there, we go back to post-processing and add a digitizing feature. Let's just add a circle here, give it a name, we'll call it clip. And it's just this little area around top right here. And I'll go back and run that again. And let's rename it to clip TIFF. And here's where you tell it to crop the image. So we can tell it to crop this to this circle named clip. And instead of putting it out at 1/2 meter, we'll put it out at say 25 centimeters, and let's try that. So that should, again, it's going to neck everything down to the boundaries of that circle, and then just output what's ever inside. Okay? So it's a kind of a neat way of making inset maps. Give you the imagery for that.
You have any layout tools like Civil 3D or Land Desktop?
Nah, not yet. Yeah, no, I thought about doing like, yeah, it'd be nice to kind of set up your whole print sheet and stuff like that, but we don't have anything like that yet. Let's see. So you can also export this thing as a website. So you can take that mosaic. I'm going to just do this at a little bit lower resolution, so it'll go faster. I'll do this at 1 meter per pixel, and you can set up the logo image that you want, the colors of the background page, and so on, and give a description of the web. You can include your contact image report as well, so you'll do that. Use the one called All Contacts. And in the interest of time, I'm not going to put all the waterfall images in here because it takes a long time to build those pages. But you can actually have a waterfall image from each Sidescan record that went into the mosaic as part of your report. So when this is done, this should also open up my web browser here, and it should have show me the mosaic and stuff in my web browser. So here's the logo image I had in here, the CCOM logo image, a little thumbnail of the mosaic, and if I click on this and maximize it here, if I move around on this image, if you're in a browser that has a status bar like Firefox or Internet Explorer, you get the cursor tracking at the bottom. It shows you the latitude and longitude as you move around. Since I asked it to hyperlink the contacts here, it's got the JavaScript in here to link that contact to the target report. So I can click down and get to all the contact information that I had in my report. Okay. That's just one of the kind of standard outputs of the web output. And you can do this with sub-bottom projects as well, so you can put your sub-bottom profiles out as well. Other exports, I mentioned we can do the Google Earth export. I don't think I really need to demonstrate that. You guys have probably seen that already. 3D viewer, we have a kind of a cheesy little 3D viewer, and we also have some exports to the IDS product, which is a lot better. Batch image export lets you take any of these files and just make JPEG images of them. So if you want to snip out something for a report, it's pretty handy. The project reports, we've got a few different project reports. Here's the coverage report I mentioned. This allows you to kind of make a color-coded map of all of your data that shows how much area you covered. Again, in the interest of time, I'm not going to show that one. I guess I am going to show it. So again, there's lots of different outputs from SonarWiz, and there's a lot of stuff that you can do with it that I'm not going to be able to get into just by lack of time here. So I'm just going to move on real quickly now to the sub-bottom project, because I know a lot of folks here are interested in sub-bottom as well. So I've got a project that I opened already and been playing around with. This is a data set from the Benthos Chirp 3, and currently what it does, you can look at data this way. It's taken the data, the vertical ribbon of data, and it's flipped it up into the horizontal plane. So you're looking at sub-bottom data, edge on. That gets some people all upset, look at it that way. So if you don't like to look at it that way, you can choose the navigation plot mode, and now you're just looking at the navigation data, okay? These red dots in here, I've already run the intersection manager. I mentioned that here in our post-processing introduction. So if I open up the intersection manager, I've already run this, and it's computed all the places where those lines crossed each other. And that's represented by these red circles. Let's zoom in here a little bit. The lines are pretty glancing. They just sort of maybe accidentally crossed each other, not intentionally. Normally you would run some tie lines on your sub-bottom survey, but if you click on these intersection points, it will show you, I think we can, this will work. It'll open up that intersection data and show you in FleeterMouse. I don't have FleeterMouse on here, but I'm looking at the 3D viewer, the free viewer. So this is just that intersection data where it crossed, right? You take a couple of hundred pings on each line and then put it in an SD file. So you might find that handy. You can also generate 3D looks at several lines, either in the FleeterMouse product. Let's just take a couple of them here real fast. So you can generate FleeterMouse SD files in either version 6 or version 7. I don't have any of the newer stuff on my laptop. So there's those two lines just very quickly, I know you can do this in Clear Mouse, but this kind of gets you there a little bit faster maybe. And you can take all your processing as well. So anything that you process in SonarWiz carries through to the export to Clear Mouse. Now these individual lines inside SonarWiz can be edited just the same way that we did with the Sidescan. So if I click on one of these lines and right click, same way I can either say digitize new features, and that'll open up that profile in a waterfall view. Again, waterfall being sideways this time. So here's that profile image. Again, we've got the cursor tracking between the image and the map. So you can see when I move the cursor around here, I've got the map correlated cursor as well. And I can do stuff like bottom tracking. If I wanted to track the seafloor here, we've got an integrated bottom tracker that you can see that. This little red line there will track the seafloor for you. Is that last call, Larry?
I just really want to see that cursor.
And that seafloor reflector can be converted to a reflector, so you can actually do some computation with it. So let's say I want to make that a seafloor reflector, and I'm going to add my own reflector. I want to digitize something in here. So let's find. Let's just pick up this little reflector right here. Let's say add reflector, and we'll call it R1. And the way reflector digitizing works in SonarWiz is it's all manual. So you just click, click, click. You can go back and put things in any order you want. And now you've got a reflector. Right? So you can imagine that you might want to do this for different horizons that you see in your data. And we have a thickness tool that lets you take any pair of reflectors, like the seafloor and the one R1 that I just digitized, and compute the thickness between them. So if you do that on a bunch of parallel lines, right, you can begin to build up a volume of maybe material that you're mapping. When you generate that thickness, what actually happens is we take all the intersecting shots between the top reflector and the bottom reflector, and we generate a file that contains an Excel file that contains X, Y, and Z, and X, Y, and thickness for all those intersecting points. I mentioned that we have a core output here, so this is the thing that you can. It's one of these buttons here that you put a core symbol on here. So you've gone out and you've done a gravity core. You can give it a name like Core 1, and then you can begin to. You take your geotechnical interpretation and you say, okay, the top layer was silt, and I had a meter of silt. And underneath that, I had some sand. Sand is always yellow. And I got, say, 3 meters of sand. And you kind of get the idea. Gravel. Okay, so then I take that core and the location that I've associated with it, and I come and I plot it on my image. And so then when I export this, that goes along with this geotechnical interpretation, kind of matches up, hopefully matches up with your acoustic record. So that's the coring bit there. Sure, I'm leaving out like about many things here, but once you've digitized all these sorts of features, you can use the feature manager then to go do something interesting with them. You can export them in lots of different ways. You can have several different file formats. You can take maybe all your R1 reflectors, maybe you digitize that reflector on one line, and the next line, and the next line, and the next line, and you want to be able to build an ISO map from all the R1 reflectors. Well, this is a tool that lets you do just that. Everything I showed you about exporting to a GeoPDF or GeoTIFF, you can do that with the same tools for exporting, so you get a map of where your track lines went. Okay, now I'm going to jump to Magnetometer because I got like 1 minute. Okay, so Magnetometer, I got a project in here for that. So SonarWiz will collect, any of the real-time systems will collect magnetometer data. So you don't need anything special for that. But we do have a magnetometer option for post-processing. So this is some data that was collected by one of our customers in the Gulf of Mexico. And those purple lines that's a shapefile that's loaded into the background. And the green lines on top are the actual mag tracks. So this is the navigation data. So just like with the other types of data, you can click on a line, right-click, and bring up a mag editor. So the mag editor is sort of a strip chart, a scrolling chart. Again, it has cursor tracking, so if you've got sonar data underneath of it, sometimes that's real helpful. But each of these spikes in here can be edited. And the neat thing about the mag data is if you've got underlying maps of pipelines like these guys do in the Gulf, you can actually identify what the probable cause for that mag anomaly is. So you use that identify cause button, and it goes and it looks in the base map that's loaded, the shapefile of all these pipelines, and it finds the nearest pipeline intersection to the mag anomaly you just clicked on. Right? So I don't know if you can see this yellow line down here. That's one of the pipelines that crosses this mag anomaly. So that's likely the cause of this anomaly. It's when you find mag anomalies that you don't know what they are, then you do some more work. But this is something that we did primarily for Fluoro, was the customer that really drove this initial development on the mag. The mag also has a nice kind of report generator. So we'll generate a report in an Excel spreadsheet here with a little chart if you want. And that should pop up in Excel when it's finished. So again, for each mag anomaly, you get a little chart that shows a snippet of the mag data where the anomaly occurred and a summary of information on it. Okay, so I'm trying to hold it to 50 minutes, so I would like to invite anyone that has questions about anything I've talked about or didn't talk about to fire away. There.
Your seismic stuff is clearly designed for high-res seismic, but is there any constraint that says if I had a nice process multi-channel line, I could bring it in, it came in as seg-wide?
Yeah, as long as it's seg-wide, it should import okay.
And it'll handle 5 seconds or?
Yeah, you can actually set up the resolution. So by default, just go back to our sublime project again. When you first load the data in, it makes an image that's always 1024 pixels tall. So it just always scales it automatically to 1024 pixels. But there's a setting in this window where you can say, okay, I want each pixel to represent a half a meter or 5 centimeters or whatever. And that's under here in this preferences button. So you can set your vertical and horizontal scaling here.
But many people use it with multi-channel?
I don't know of anyone that has, to be honest with you.
Usually they can afford to collect multi-channel. They can afford $300,000.
Yeah, exactly. They can afford it, yeah.
What do you use for sound speed for bottom data?
Yeah, it's a acknowledge a shortcoming there. So we have a single sound velocity that you enter, and we definitely acknowledge that we need to be able to have a profile of sound velocities. Yeah, because now you've got a single value for the water column that's not going to be valid for the sediment and stuff like that, but it's on the list.
So you're using a single value for both water column and the sediment?
Yeah.
So for the sound speed and the sediment, you're using the same as for the water column?
Yeah. We only have a single sound velocity right now. You see that's a big item here. Oh, we know it's a shortcoming, but yeah, that's the way it is. That's the honest. Yep.
Can you display a multi-beam backscatter?
Yeah, anything. The software is pretty flexible for allowing you to bring in different types of background maps. So when you go to add a map, it's got a zillion different map formats. I know you can't read these, but anything, basically almost anything you can bring into your ARC. We use a product, we license a product called Global Mapper, which is kind of like a funnel for map types. And it's a great product, low cost. And somebody else likes it. But yeah, so anything like, what kind of data do you have, Andy? What format's it in?
Well, like a Kongsberg multi-beam EM302, say.
Like a not all
Oh, you're talking
process
about
data, right?
Yeah,
so
you
these are
want-
These are
process
process data, not
Yeah,
raw.
it won't take in the raw data.
No, it won't take in the raw data.
So no native, not any native, you couldn't do it sort of online with native process. But if you had XTF or GSF or...
Oh yeah, I mean it'll read in backscatter from all of those. It'll read in some, like we can read in the RDF, the backscatter from the RDF, the GeoSWAP tool, the backscatter from the SWAP Plus, which is called SEA's product. And I think there's one other one. I don't know if it's the Resound or anything that you collect with HiPAC too. So anything in HSX format, you can read the backscatter out of that. But if you've made a grid, if you process the bathymetry in something else, you can bring that processed grid in as a background map. And that can be even an ASCII file. You know, if you've got X, Y, and Z, you can bring that in. Yep.
If you have multi-beam underlying, is there a possibility of using that bathymetry when you're doing the processing on the side?
Yeah, like what Geocoder would do. We don't have anything that looks at, you know, the slope right now.
How about projections?
Projections is, you're gonna like that, I think. We use an open source library for projections, so. It's not Crotch, it's actually, it was commercial when we first started using it. We bought it and then it went open source to AutoCAD, not called AutoCAD, whatever the company that makes AutoCAD. Autodesk. Yeah, when they bought this company, it became public domain. But you can choose, by default it uses UTM if you don't specify anything, but you can choose from a wide range of coordinate systems, and you can even make your own. So,
And you can change the parameters within.
yeah, you can create your own datum and you can create your own ellipsoid. You can work on Neptune if you want to.
And believe me, I have.
Yeah.
Really screwed things up. My screwing it up, not the software.
John, do you give external access into your contact database?
It's just a SQLite database,
Oh,
it's
it is,
DB3.
right,
So
okay.
you can, I mean, we could open up this project. We go to, it's my favorite tool here is this one here called Open Project Folder, because I'm too old to remember anything anymore. There should be a DB3 file here. It is right here. So contact something.db3. And if you open it up, you know, there's lots of programs, open source programs that'll read it. So we save all kinds of stuff in here, like the last reports you made. Here's contact data, and table data. So yeah, we should see. Yeah, it's all in here, Lindsay.
So you could read and we could write into that. In fact, if we could read and write separately, with
so
update
if
in
you could read, yeah, you could read right into it and save the image in a common image format,
Right.
and we can display it.
On your track intersects, can you do stats, crossover analysis?
We don't yet, but we're really open to ideas because, you know, we're not experts. We're experts in very few things, except for programming maybe, and that's even questionable. So we've got some ideas. You know, by all means, you know, that's just kind of how all this stuff ended up in here. Is what you guys suggested. So, yeah.
I was interested in that classification tool, and I've got both a comment and a question on that. The comment is, it seems like the results of that classification are going to depend really heavily on any type of signal processing that you do up front. So you showed, for example, some gain control or other signal processing you can do. My guess is that if that's based on trying to create an image that's visually appealing or good for visual interpretation, that might not necessarily be what's best for getting the best classification image on. And then the question is just, with the wealth of different classification algorithms that are out there, primarily from the remote sensing community, doing different types of texture-based classification, how did you pick the one specific algorithm that you implemented here?
It was the easiest one. Well, all the things you say are true, I think. Yeah, the way you do your signal processing is going to definitely affect. But I think that's true for any of the classification systems that are out there. It's just an idea that we wanted to try. We're not charging for it. It's in there. You know, we've been comparing it with Western Tangent, which I think is sort of the state of the art for probably the industry. It seems like that's what most people use. And we just wanted to have a go at trying a couple of different ideas. So we're not really pushing SonarWiz as the classification software to use by any means. It's something that we're trying out, and maybe it'll stay in the product and maybe it won't. The way that it's designed, it's easy to plug in different algorithms. We've got this real nice class model for that. So yeah, we'll see where it goes. I guess I don't have a good answer. I'm not an expert on Seabed classification by any means. And it's something that we're just kind of playing around with, I guess.
Do you generate metadata with each one of these things that would track what you've done to it, like the AVG?
Yeah,
That kind of stuff?
we've got something, I think I mentioned, that Sonar file manager. So you can get a report out of that guy that, I think this gives you a spreadsheet here too, that kind of tells you what's been done. Yeah, so whether TVG is on or off, what's been turned on and off on it. It's like, yeah, EGM's on here.
But it doesn't really tell you it's only the basic TVGs on or off.
Doesn't give you the settings.
Yeah,
Exactly
no
what you're
settings.
after. Yeah. Yeah, no, that's maybe one for the wish list. You know, you
Yeah.
can, we can submit that stuff on our support site if you have some good ideas.
Oh, don't tell him that.
Yeah.
He'll just call you, John.
Right.
With version 5, are you aware of any problems with bringing in Knudsen 3260 data for the bottom?
In the KEB format?
Or SegY?
The SegY normally works pretty well. Like, okay, the thing with SegY.
In 4, we had some problems on the Okeanos Explorer, so I'm going to upgrade when I go out next
Okay.
time.
Yeah, just obviously let me know, or let us know if you've got issues with the sub-bottom. The thing I was going to say with the SegY is like the SegY is so everybody takes their liberty with it, right? So we've got this hairy dialogue that tries to compensate for it. So some people will put like event number over here, and some people will put anything anywhere. And so it's kind of hard to predict what you're going to see as a developer. It's hard to prepare for that. So we have this dialogue that says, okay, the sensor depth is in these bytes, the sensor altitude are in these bytes, and so on. And that kind of helps. And once you set that up for your particular data set, you can save these profiles. And you might find that helps. What I do sometimes, I use SizeView. It's that free SegY viewer from, I think it's from a guy in Russia. And that's actually pretty good because you can look at things in there and kind of figure out what you got. If you get stuck and you can't import it, and then you come back to this dialogue and kind of match that up with what you see in SizeView.
From your accounts, you recorded in SegY, not in the KB?
We don't record it very often, and when we do, we record everything, different formats.
Well, you have to choose one or the other.
I think the problem was I was on the Okeanos, they were recording it with extended KEB format, which there's nothing that can convert that to SegY. So I talked to Knudsen about that problem. So there's two KEB formats. There's what they call an extended KEB, and then there's KEB, and then there's SegY. And when I converted on the Okeanos over to SegY, I had no problem at all in reading it with Sonar, the famous Sonar Web.
Right, John, what was the name of that SegY viewer?
It's called SizeView, I think. Yeah,
Yeah, I've got it.
yeah. It's pretty good.
We got a question from the
Oh.
audience, internet audience.
Any other questions? This is your chance. All right, thank you.